Hi again, welcome to this physics section where we are going to revise where the formulas come from. In particular, we are going to look at three formulas. We're going to look at the formulas for the orbital speed, the formula for the escape speed, and the formula for the orbital period. Okay, three formulas or three equations. When we talk about the orbital speed, in order to derive this formula, remember that the satellite is orbiting in a circular motion. When you've got circular motion, you've got the centripetal force, which is of the kind mv squared over r, where r is the radius of the orbit, okay, or the radius of your circle, and m is the mass of the object. So if you got a satellite S orbiting around a big planet M, okay, and that would represent the trajectory, right? Then this mass that you've got here is the mass of the satellite. This is the velocity of the satellite, and this is the distance from uppercase M to lowercase m. Now, the centripetal force can be set equal to the force responsible for this movement. Who's responsible for the movement? Well, gravity, the gravitational force. And that's where you start from when deriving this formula. If you just substitute with all the formulas you know, with algebra you will derive this other formula. So let's look at the step. Gravitational force, ignore the minus, because we look at the magnitude. Simplify, m and m goes away, r and r can be simplified, and then make v the subject by taking the square root. Okay, let's look at the other formula, the escape speed. Now, when you've got the escape speed, what you want is your object to run away from the orbit, to get away from the planet. Okay, so you want the object to be able to eventually get to infinity with the minimum possible speed. So you need the minimum energy to take it to infinity. So that means that at infinity, eventually your object will arrive with speed equal to 0. So, with an energy equal to 0. So that's what you said. You said the mechanical energy at infinity equal to 0. But we know that the mechanical energy at infinity is given by the kinetic energy and the potential energy. Okay? So this one is kinetic energy, and the other one is the potential energy. The formula we've seen earlier on. Kinetic energy half mv squared. We are talking about escape speed, so we call it escape speed here. Potential energy, we didn't derive it, but we saw the formula. Same as before, simplify as much as possible. M and M goes away. Make V the subject. Okay? So you take the square root, and that's what you're left with. Why do we choose the Earth here? Well, because you've got a satellite that you've got just at the surface of your planet. Imagine that this is the Earth. You've got Houston, let's say, that is delivering a satellite in orbit, and it wants the satellite to escape the gravitational attraction of the Earth. So Houston wants to deliver the satellite that gets to till infinity, right? So when the initial condition is when you're here at the surface. At the surface, you need to use the radius of the Earth. And the escape speed is the one that Houston needs to provide for the orbit to take off and run away. Okay? Right, so escape speed, orbital speed. Now we're left with the orbital period. When we look at the formula for the orbital period again, you need to compare the gravitational force, which is the one responsible for the movement, with the type of movement that the satellite is making. The satellite is on a circular orbit. Therefore, the gravitational force, and here we forgot about, hold on, there was a symbol that went away. They are not meant to be here, okay? the gravitational force is equal to the centripetal force. So again, plug in the formulas you already know, the one for the gravitational force, without the minus, no need for the minus, and the centripetal force, mv squared over r. So that's the cause for the object. Now, if we want to find an expression for t, we need to rearrange these two formulas using something with t the period. Well, but recall that in the centripetal force, we've got another expression, which is F centripetal is equal to m omega squared times r, where r omega is the angular velocity, and omega is equal to 2 pi f, where f is the frequency, okay? And f is 1 over t, so 2 pi 1 over t, where t is the period. So by replacing this expression for omega into the centripetal force, and then once you got omega here, you put it into this formula. Where is it here? You just manipulate with some algebra. So for omega, use this formula. Okay, 2 pi over t, so 4 pi squared over t squared. You got the r. The m went away because we simplify here. And then